Okay, welcome back. So when we deal with astronomy, when we get started with astronomy, one of the most difficult things is to deal with the enormous size scales and time scales involved with astronomy. It's really easy in astronomy just to have everything be really, really big and really, really old, but that's really not that helpful when we're trying to be specific and trying to understand different evolutionary processes that may operate on very different, though very long, time scales. So for example, the age of the Earth is 4.5 billion years, right? And the dinosaurs were wiped out about 65 million years ago. How do you hold those two numbers in your hand and make sense of them, right? The way that scientists do this is through something called scientific notation. That's how we deal with large numbers. So the age of the Earth is 4.5 billion years old, but that gets written as 4.5 times 10 to the 9 years. There's the first part of the number, the 4.5, which tells you where you are in your order of magnitude. But the important part is the order of magnitude, and that's the 10 to the 9. It's the exponent on the 10. So we're talking about 9 powers of 10, essentially, for the age of the Earth. Now, all of that may have not made much sense to you, so let's try and use something that is familiar to all of us in order to understand the scientific notation. And let's use money, right? Because we all understand the power of money, and we all know how much money we have in our bank accounts or in our hand and what it feels like. So what we're going to do is we're going to think about dollars. We're going to run through a set of examples thinking about dollars and thinking about those dollars in terms of order of magnitude. So let's start off with, let's say you have a dollar. We all know what a dollar is, and what can a dollar buy, right? Well, basically these days a dollar will buy you a Snickers bar. Okay, so $1 gets you a Snickers bar. You know, and if you like Snickers bar, that's great, but you're not going to be able to go much further than that. So how about one order of magnitude more? Let's jump up one order of magnitude, $10, and what will that buy you? Well, essentially $10 will get you a, kind of bad compilation CD of 70s hits, or a really great one, perhaps, of Bob Marley, depending on, which store you go to. But that's what $10. Well, you jump one order of magnitude, and we go from a Snickers bar to a CD. And what about the next order of magnitude? That would be going up to 10 to the 2, 10 raised to the 2 power of dollars, $100. And what will that get you? Well, that'll get you dinner at a nice restaurant. Not the fanciest restaurant, but a pretty fancy restaurant. $100 should get you there. So in 2 orders of magnitude, we've gone from a Snickers bar, which isn't going to do much for you, to, a nice restaurant. Okay. How about 3 orders of magnitude, $1,000? Well, $1,000 will get you a plane ticket, to someplace nice, perhaps to, a nice vacation. Okay. So $1,000, 3 orders of magnitude, takes us from the Snickers bar to the ride on the jet plane. One more order of magnitude, and that will take us up to a luxury car. Now, of course, you're not going to be able to get a luxury car for $10,000, but maybe for $60,000 or $70,000 or $80,000. Again, this is what we mean by order of magnitude. You might be able to at least, get started on a luxury car. Okay, so that is 4 orders of magnitude from the Snickers bar to driving around in, a nice sports coupe. How about 5 orders of magnitude? Well, 5 orders of magnitude will take you to, being able to get a nice apartment, perhaps, that you could use while you're driving around your sports coupe. So, $1,000 got you a plane ticket to a nice place, could be Paris. 10 to the $4, tens of thousands of dollars get you a sports coupe to drive around in Paris, and hundreds of thousands of dollars will maybe get you an apartment in Paris. Okay, so just 5 orders of magnitude. That's really what you have to think about. Just 5 orders of magnitude took us from a Snickers bar to an expensive apartment in a nice city. Okay, and that is the important thing to see. It's just 5 orders of magnitude, what the difference, the physical difference in our experience would be in having that much money. Now, in astronomy, we may easily jump 15, 20 orders of magnitude in both size and time scale, going from one kind of physical process to another. So getting a handle on orders of magnitude would be a really essential thing for being able to understand the rest of the class. Okay.